Ladies and gentlemen, I have a question. What are black holes? Well, the answer to that question is very simple. A black hole, as it says here, is a place in space where gravity pulls so much that even light cannot get out. That's why when we take pictures of black holes, we can't see anything inside. We just see darkness because we just see nothing from inside. The gravity is so strong because the matter has been squished in a tiny space. This tiny space is a singularity, which we'll talk about it later. This can happen when a star is dying. Because no light can get out, people can't see black holes. I told you, they are invisible. I have a question. Do you know what spaghettification is? No, it's not this. No, 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 no. It's not this. Well, to answer that question, we have to go out to outer space. Well, spaghettification, as Google says, is technically the tidal effect caused by strong gravitational fields. And when falling towards a black hole, for example, the object is stretched in the direction of the black hole and compressed in the particular to it as it falls. And this image is actually pretty good explanation. As you see, it's curving into the black hole's gravitational field. And when you really spaghettify, your legs stretch the most, although the rest of the body still stretches a lot. Your legs stretch the most. So I've rang Google, and let's say this diagram. Um, As it shows, it's like a black hole. Everything is worked near the inside, and the inside there's a little dot, kind of dot, like zero-dimensional dot under here, and that dot's mass is the singularity, which the mass is insane. It's infinity, and you see this curvature of the black hole in the image. Technically, that much curvature gives the black hole the amount of mass and power it has. Um, uh, the when very big stars actually die, they don't turn to supernovas. They actually turn to black holes, and that's how many black holes are made. The stars have a lot of mass, but when they collapse at the end of their life, eventually collapse to their singularity that makes enough force to make a black hole. And we have this nice diagram uh, that I'm going to talk about later. Okay, so now we're going to talk about this diagram. It's pretty easy to get when you understand it, but it seems very complex at first. Okay? So you see this dark bit inside the black hole. The dark bit inside the black hole is the part that we can't see. It's the part after the event horizon. It's the you see the event horizon where nothing can go past, not even light. So you can't escape. So now it appears as black because even light can make it look like anything. It doesn't look like anything to us. And so I'm going to explain this to you. So over here it says this the accretion disk, which is a hot, thin, rotating disk formed of matter slowly spiraling towards the black hole. That's technically what the black hole is going to eat after a long while. The accretion disk has a very fast speed, up to something near the speed of light. It's very fast. And let's now talk about the photon ring. The ring of light is composed of multiple distorted images of the disk. These lights making up these images have orbited the black hole two, three, or even more times before escaping us. they become thinner and fainter to the black hole. Okay, now let's explain the black hole shadow. It's technically an area roughly twice the size of the event horizon, which is the black hole's point of no return, as I told you before. That's formed by its gravitational lensing and capturing of light rays. Okay, now let's talk about the image of disks on their side. So it's like the light rays from beneath the far side of the disk are gravitationally lensed to produce this part of the image. Okay, now let's explain the Doppler beaming. So that is technically light glowing in gas in the accretion disk, which is brighter on the side where matter is moving towards us, the fainter on the side where it's moving away from us. Okay, now we're going to talk about image of the disk's far side. The black hole's gravitational field alerts the path of light from the far side of the disk, producing this part of the image. Okay, so now I'm going to talk about what would I see if, let's say, I had my friend Bob, and my friend Bob went into this black hole. What would I see, and what would our predictions say would happen for Bob? Okay, so Bob is getting closer and closer. When it's getting closer, it's stretching for spaghettification, and when it gets very close, when it passes the event horizon, because light can't pass that, so you see, like, the reason why my hand is like this color exactly is because light is hitting my hand, and then light is white, okay? And white is made of every color. So only this special color comes out of my skin that we see. Let's say this mouse, it has a gray bit. That's when the light from the sun or something that has light hits it, and when it hits it, only the um, gray side appears to be here. And so, as you see, all the colors, it gets all the colors inside it, but the gray color bounces off and we can see it. So it's pretty simple. And when you go in a black hole, there's no light to bounce off you because the light can't bounce off in the event horizon because that's the point of no return. That's why everything there is black. So I would see my friend Bob disappearing. I would see them fade. Thanks for watching.